In this video, we're going to talk about how to complete the square. So in this problem, we have x squared plus 4x equals 21. The first step when you complete the square is to be sure that the squared term here has a coefficient of 1, and in this case it already does, so we don't have to do anything. The second step is to make sure that the constant is on the right hand side of the equation, which this one is as well. So we can jump down to the third step, and the third step, what we're going to do is add a couple of boxes so that we know where we're going to put our constant term. And now to figure out what goes in this constant term, what we have to do is take half of this linear term here, which is 4. So I'm going to take 4 divided by 2, which is 2. And then you have to square that number. So 2 squared is 4. So this is the number that's going to go in the box now. So I'm going to add 4 here and add 4 here. So now I'm left with x squared plus 4x plus 4 equals 25, because 21 plus 4 is 25. And now what we can do is rewrite this as a binomial. It's going to be x plus 2 squared. This number here always comes from whatever this number is. So we have x plus 2, that whole thing squared, equals 25. And then we subtract the constant back over to the other side. And now we have completed the square. And so from here we can solve and figure out what x is. But for now we're just going to complete the square. Alright, let's say we have a problem that looks like this. 2x squared plus 8x minus 10 equals 0. Again, the first step is to make sure that the squared term has a coefficient of 1. It doesn't in this case, so what I have to do is turn it into a 1. And I can do that by dividing everything by 2 here. So 2 divided by 2 is just 1. X squared plus 8 divided by 2 is 4, and then 10 divided by 2 is 5, 0 divided by 2 is 0. So I'm now going to complete the square on x squared plus 4x minus 5. The next step is to move this constant term over to the other side. I'm going to add it over. So now I have x squared plus 4x equals 5. The next step, remember, is to add your boxes so that you know which constants you're going to add now. And then to figure out what number goes in that box, you have to take half of the linear term, so 4 divided by 2, which is 2, and then I have to square that, so 2 squared is 4. So that's the number that goes in my boxes here. Now we have x squared plus 4x plus 4 equals 9. Now we'll have to simplify this into x plus 2, whole thing squared. Remember, that comes from this number here. That's the number that you got when you took half of this linear term here. So again, 4 divided by 2 is 2, which goes here. That's going to equal 9. And then we'll subtract that constant back over. And now we've completed the square. We'll do one more. Let's say we have a problem that looks like this. 3x squared plus 10x plus 3 equals 0. We have the exact same steps that we have to follow. So the first thing is to see if the squared term has a coefficient of 1, which it does not. So now I need to divide everything by 3 so that I can turn that into a 1. So that gives me 1x squared plus 10 over 3x plus 1 equals 0. Then you have to move the constant to the right side. So I subtract a 1 here. So I get x squared plus 10 over 3x equals negative 1. Now we have to draw in our boxes to figure out which constants we're adding. Again, we'll take half of the linear term. So our linear term here is 10 over 3. We want to take all of that divided by 2. If you use your calculator, be sure that you put 10 over 3 in parentheses. Divide that by 2, that turns into 5 over 3. And then of course we want to square that. Notice again how I use parentheses. So that's going to give me 25 over 9. So those are the numbers I'm going to add to the box here. 25 over 9. Okay, so now we have x squared plus 10 over 3x plus 25 over 9 equals negative 1 plus 25 over 9 is 16 over 9. And then we will simplify this piece right here into a binomial, which again comes from this. So we have x plus 5/3 squared equals 16 over 9, and then we can subtract that back over. And now we've completed the square. In a different video, we're going to learn how to use this to convert the standard form of a quadratic to a vertex form, and we'll also use this method to solve quadratic equations.